Protein is perhaps the most discussed macronutrient in the context of health and aging, and yet some of the most important dimensions of protein quality remain poorly understood by the general public. The conversation is typically framed around quantity: how many grams per day, how many grams per kilogram of body weight, while the question of quality receives far less attention than it deserves. For older adults navigating reduced appetite, smaller meal volumes, and metabolic changes that make efficient protein utilization increasingly important, protein quality may actually matter more than protein quantity in some respects. The 9 essential amino acids, those the body cannot synthesize and must obtain from diet, are required simultaneously and in appropriate ratios for protein synthesis to proceed efficiently. When any essential amino acid falls below a required level, protein synthesis is limited by that bottleneck, regardless of how much of the others are available. This is the concept of the limiting amino acid, and it is where the distinction between animal and plant proteins becomes practically significant. Animal proteins, meat, fish, eggs, dairy contain all 9 essential amino acids in proportions that closely match human tissue requirements. This is why they score near the top of protein quality assessment systems like the Digestible Indispensable Amino Acid Score, or DAS, which is considered the most accurate current method for evaluating protein quality. Individual plant proteins almost always have at least one limiting amino acid. Lysine is typically limiting in grain-based proteins, while methionine is often limiting in legume proteins. This is why traditional food cultures that relied heavily on plant proteins universally developed complementary protein pairing rice and beans, corn and legumes to compensate for what any individual plant protein lacked. For a young adult eating large and varied meals, this presents little practical challenge. Complementary proteins can be assembled across the day without precise meal-by-meal planning. But for an older adult eating smaller volumes, experiencing early satiety, or relying on a limited number of familiar foods, the efficiency gap between animal and plant proteins becomes more consequential. Getting all essential amino acids in sufficient quantities from smaller meal portions is more reliably accomplished with animal proteins than with plant proteins that require deliberate combination. The digestibility dimension compounds this. Plant proteins are encased in cell walls and associated with fiber, phytates, and other compounds that reduce digestive breakdown. Animal proteins, absent these structural barriers, are more completely digested and their amino acids more fully absorbed. DAS scores reflect this, and they show consistent and meaningful advantages for animal proteins across the board. None of this is an argument against plant proteins. They are nutritionally valuable, affordable, and compatible with excellent health outcomes when consumed intelligently. But in the specific context of older adults trying to maintain muscle mass on diminishing appetite, the case for prioritizing animal proteins is strong, and the recommendation to increase plant protein at the expense of animal protein in aging populations, which appears in some dietary guidance, deserves considerably more scrutiny than it has typically received.